It's recording. All right. So 10E and F, you're practicing maximum minimums, absolute max, absolute minimum. So we already talked about in the previous exercise, local max, local minimum. How do you find local max, local minimum? Again, can I please have, let's go with Aryan. How do we find local max and local minimum? You let something. Not sure? Not sure, Vibha? How do you find local max and local minimum? The gradient equals 0, which means the derivative delta y delta x equals 0, because local max and local minimum just means a turning point. Okay, so this is called a local max. This is called a local minimum. We know that at a turning point, the gradient of a tangent line is 0. So there are 3 types of stationary points. Those are the first 2. Next one, absolute max and absolute minimum just simply means the highest or lowest point anywhere on the curve. And when we say point, we're referring to the y value. Okay, so when you look at a graph, where is the highest y value and where's the lowest high value? That's called your absolute max, absolute minimum. What's the skill in this exercise? Sometimes you could get a graph that looks like this. So usually they give you a cubic graph, one that you can't picture in your head, and they'll give you an interval. So they might say it looks something like this. So it might go from 0 to 5, for example. So if you can see the graph, it's obvious where the maximum and where the minimum is. We can tell that absolute max, this is the highest y value you can have. So this is called absolute max. We can see that the smallest y value is definitely down here. This is called the absolute minimum. But it also turns out that this is a turning point. So we also call that local minimum. So the skill is that without this picture, when you find the derivative, you're able to find these stationary points. So imagine I put these points in. I put a pot here, so that's local max. I got a point here, that's local minimum. And then I cross this off. I take off the blue graph. And you have the endpoints, which you have to calculate. If it was from 0 at x equals 0 and at x equals 5, we found out the y value is here, and we know that the y value is here. You're then meant to look at these points and say, look, I don't know if it's a max or a minimum. I just know they're stationary points. But what would my absolute max and absolute minimum be? Well, logically, the y value here, you do all the comparison of the y values. Where's the highest y value? Where's the lowest y value? And you're using the endpoints and stationary points to kind of tell you, because the stationary points have to occur if it grows and then it decreases. So that's the only way, whether it's a minimum or a maximum, this must be the highest value, and then this must be the lowest value. That's why you need endpoints and stationary points. Okay, so if I had to summarize the skill here, is you're utilizing endpoints and stationary points. So with a graph for the first example, I don't know what that looks like. 1 over x minus 1 plus 1 over 4 minus x. I can't picture it without a CAS calculator. They gave me an interval, so 2 to 3. So they're saying the minimum x value is 2. Maximum x value is 3. So if you think about a number line, here's a number line. 2 to 3. Y values could be up or below. I just don't know where it is. My goal now is to visualize, if I just found the endpoints, let's say it was, I don't know, here and here, is that the absolute max, absolute minimum? That's why we then have to find the derivative, find any stationary points in part B. You have to find a stationary point, because if there's a stationary point, it might be that it was growing and then there was a decrease. The stationary point would imply maybe this y value is the highest y value. That's why the endpoints don't tell me anything. The question is, where is the stationary, if there's even any? If there's a stationary point here, well, then that might just be like, it goes like that. Then still, this is still absolute max, that's still absolute minimum. So the problem is, where is the stationary point and where are my endpoints in terms of y values. That's the skill of exercise 10E and 10F. That's all you have to take away from it. Yeah? But in order to do that without a cow's calculator, you have to know the skills. So first one, A, find the derivative of f of x, which is currently 1 on x minus 1 plus 1 on 4 minus x. So this is going back to chapter 9, which I assume most of you have already done chapter 9. Let's see. How do you derive the first one? 1 on x minus 1. What would you do, Krish? Beautiful. So you rearrange it. F of x is still the same thing, except this time I'm writing it with the power of negative 1. So I'm bringing the denominator to the numerator, and that's to the power of negative 1. Basic index laws. Why do we do that, though? How would I then differentiate this to find f dash of x? Let's go with Zach. How would you differentiate this?
Well, you can do, or you just use the power of x, so then you times negative 1. And I mean, you could use the chain rule, but it's not really necessary. You just do it in your head, so it just times x minus 1.
Beautiful. Technically, there is a chain rule, but the reason why it is unnecessary is because
You just square it, like you just do it in your head.
yes, you can do it in your head.
It's time when you differentiate the x, it just turns to 1.
Beautiful. If you differentiate the inside, x minus 1, it's still just 1. That's why it doesn't actually matter. Differentiating the outside, which is to the power of 1 minus 1, and that's why you can just do that in your head, and technically that should give you negative bracket x minus 1 to the power of negative 2. Okay, so that's using chain rule essentially, and yes, it is. Derive inside and then derive outside. Let's do the same thing for the next one. Let's go with Phoenix. Derive the second one for me. Like that? One mistake. Positive y.
Because the power is negative.
Very good. So one of the key things is remember, derive the inside, there's that negative 1, and they often do that in the exams in the past. And they still kind of embed it in, but if you derive this is not 1. Derivative of this is actually negative 1. And then doing what Zach said before, if you brought the power down, using power rule, so negative 1 times negative 1, but don't forget to minus the power by 1 as well. That's why you then end up with a positive 1 bracket 4 minus x to the power of negative 2. Okay? Which really is just the same thing as writing negative 1 over x minus 1 all squared plus 1 over 4 minus x all squared. Okay? So that was the first part. So we found the derivative. Why do we find the derivative? Because remember, there's two things that you're going to observe. You're going to find the endpoints, and then you're going to find the stat points. But to find stat points, you need the derivative. So here we go. To find stat points, at the start of this session, we just said stat points occur when the derivative equals 0. So here's your next challenge. So you're now trying to solve 0 is equal to negative 1 over x minus 1 squared plus 1 over 4 minus x all squared. How do you solve this now? Because you're trying to solve for x. If you can find x, that means you can find the stationary points or the x coordinate of it. How do you solve this scenario? Can I please have, let's go with Adonis now. This scenario, what are you going to do to solve for x? Move which one? Okay, so we're going to move this one. Cross multiply, as in these two. Okay, so what would I get? Over okay, good. Seem to be unsure that. Now what's the next step, which is the key step? Now we're trying to solve for x. So it's a good start. Cross method could also work, so you combine them as a fraction. I probably would have just grabbed this entire fraction and moved it across. Okay, so that would have been a bit easier, but this method still works. But I have seen a lot of students get up to this step and then they give up. What do you do when you get up to this step? If you combine it as one huge fraction, the numerator is this one and that's your denominator. What do you do? Solve for x, especially when it's equal to 0. You could use null factor law, but in order to do null factor law, you need 2 factorized brackets. At the moment, they're not factorized. This one's factorized, but it's a denominator. What's the next step?
Just get rid of the bottom.
Why?
Because the top has to equal 0.
The top has to equal to 0, and you can get rid of the bottom. Remember, through algebra, BODMAS, this means divide. Opposite of divide is times. I can actually times both sides by the denominator. And if you do that, times this side by whatever I just said, they're going to cancel out. So these cancel out, these cancel out, these cancel out, and you end up with 0 is equal to negative 4 minus x squared plus x minus 1 squared, which looks a bit more scary, right? Whereas the one that I was proposing before, had you just moved this fraction across, your equation would have been a lot easier in the sense that it would have been 1 over x minus 1 squared is equal to 1 over 4 minus x squared. Now you can do the cross simplify, and you will end up with 4 minus x squared is equal to x minus 1 squared, which to me is a lot cleaner than this approach. But there's nothing wrong with this approach. Okay, it just means you have to be strong with your algebra as you're moving things across. So from here, how do you get my same answer? You move this part. That's a negative bracket. Move it across. That's how you end up with the same 4 minus x all squared is equal to x minus 1 squared. We're almost there though. We still haven't solved the problem. I like this kind of fraction problem because they're often put in the exams. You have to get familiar with working with fractions. Yeah. So from there, I want to solve for x. What's the next step? Charlie? Don't expand. If you expand, it makes it even more complicated. Well, you can do that too though. But there's a shorter way. What's a shorter way? Square root both sides. Always try to find a simplify. When you expand, it makes it worse. Factorizing is simplifying. So here, a better way would then be square rooting both sides since they're both being squared. Yep.
If your domain was a positive, then you'd be neglecting negative solution plus square rooting.
Yes, that's right. That would be one that you'd have to consider. That's correct. But given that we already know domain is 2 to 3, then square rooting should be fine. So from there, we can then square root both sides. This now gives us a nice simple answer of 4 minus x is equal to x minus 1. And removing everything across, that would give you what? 2x equals to 5. And therefore, what's that now? 5 on 2. But yes, caveat to just square rooting, you do have to check if everything else is valid as well. Otherwise, the other way would be what Charlie said, expand it all, rearrange the terms, and then you should be able to then factorize and simplify. Okay? All right, so we finally got x equals 5 on 2, but you still haven't answered the question. Why?
Because it's asking for coordinates, not just x.
Good. We do that in the SAC. So if I say coordinates and you give me that, I'm not giving you full marks on that. Okay, so this is just finding the x coordinate. I do want to know the y coordinate as well, so you're going to give it to me in coordinates. How do you then find the y coordinate? Resubstitute x back into the function. Not the derivative, the function. So the function is 1 over x minus 1. So it's 1 over, you can think of 5 on 2 as 2.5. So 2.5 minus 1. And plus 1 on 4 minus 2.5. Turns out that would be 1 over 1.5. Yeah, 1.5, which is 3 over 2. Plus 1 over 3 over 2 again. Out of curiosity, do you know what to do from here? Apparently in the VCA exams or assessors reports, they often say students struggle doing this bit. How do you simplify that? I teach my year 8s this too. And they're like, oh, so scary. I'm like, yeah, I know. My year 12s find it scary too. How do we do this, Krish? 1 times 2 and 3, because this actually just means 1. This symbol here means divide. 3 over 2. So that's why I'm teaching my 8s right now. Fractions, division. They call it KFC method. keep the first fraction, flip the second, change the sign. So it becomes 1 times, like what Chris said, 2/3. So really, this ends up being 2/3 plus 2/3, so you get 4/3, which is about 1 1/3. So 1.3333 onwards. So going back to my point again, what was the point of this exercise? It was for you to visualize from a domain of 2 to 3, we found that in the middle, 2.5, there was a coordinate for the stationary point at 2.5, 1 1/3. We don't know if that's the maximum, absolute max, or absolute minimum. So you need to find the endpoints now. Find the y value of each endpoint. So at x equals 2, what's f of 2? At x equals 3, what's f of 3? So we can do a comparison. F of 2 would just be 1 over 2 minus 1 plus 1 over 4 minus 2. Works out to be 1 over 1 plus 1 and 2. So that's the same thing as saying 1.5. So this is 1.5, which is a bit higher. So 1.5. And then you do the same for 3. That's 1 over 3 minus 1 plus 1 over 4 minus 3. And you end up the same thing. Half plus 1. So 1.5. So what can we say? 1.5. Did I do a mistake? No? Oh, it was just for me to understand. Some students struggle with improper. So if I left it like 32.15, students find it hard to visualize on the number scale. But if I change 32.15 to 6 2/5, then they're like, oh, 6.4. They know where it is. So I write 1.5 just to help you guys understand my thinking. Yeah. So now we can compare 1.5 to 1 1/3 is a little bit less, and then 1.5. Between those 2 points, we can see, even though I don't know what the graph technically looks like, I can already say that it must have been a decrease to get to a turning point, to then change the direction and then go up between 2 and 3. So from this point, I can already say absolute max is at 1.5 and absolute minimum is at 1 1/3. And that's the skill that you want to apply in 10E and 10F. That's mainly what they're trying to get you to do. And in an exam, they often give you, as a multiple choice section, a function and that, or exam 1, they give you a function and an interval. Your job is to figure that out. Okay? That's the essence. Now, the next page, there's a really cool question, and I've really tried to scaffold you with my guidance on that one. I'm going to give you maybe 6 minutes, just because I've given you guidance on how to solve it. Otherwise, it would have taken a bit longer. 6 minutes. See if you can solve it yourself to find out the maximum area of this cool question. Oh, whoa. I got the answers there. Let me just delete. Actually, you got it on your sheet. Can you go onto the back of the page? It's a trapezium. It's not this one. It's on the back of the page. A trapezium. It's a really nice question. I did guide you with some pointers, but you still have to do a bit of algebra to get to the final answer. And if you do use a calculator, which you have to, it comes out to be a nice irrational number. Okay, so I'm going to pause. Let's continue. So, let's see if you picked up some ideas. So we want to find the area of the trapezium. Part A wants you to find the length of BC in terms of theta. So BC is up here. Hint was to see if you can find the right angled triangle, which looks like this. That right angled triangle, you then can write it in terms of theta, because you know that the radius is 4. So this is 4. That is 4 as well. So that will bring you to this bit here where I tried to guide you, and I said DOC should be equivalent to OCP or OCB. Okay, because it's angle of elevation and angle of depression. So those two are alternate angles in parallel lines. Therefore, they must be equal. Okay, that's the only part that we know that's equal. So that was the first step. Second step, look at the right angle triangle. Thanks. Thanks, boys. Next one is the right angle triangle. I just chose CPO based on the diagram. I made up the center as P. It's a right angle triangle, so CPO. If that's hypotenuse, then how do you find the adjacent and opposite? Remember, cos of theta is equal to adjacent over hypotenuse. Since you know h is 4, it's a over 4. So if you rearrange it, a equals to 4 cos of theta. So that's how I know adjacent equals to 4 cos theta and opposite is 4 sine theta. Okay? So why do I want to know that this is 4 cos theta? Is because then together, BC must be a double length. So double of 4 cos theta, BC is equal to 4 cos theta, 8 cos theta. Okay, so that was the key step. Can I get a show of hands who were able to do part A, find BC? Okay, for only the people who actually tried to do it. Cool. So it was 8 cos theta to find part A. Once you know A, you can now find the area of a trapezium because the area of a trapezium is given by this rule. Half A plus B times height. You've got A plus B, which is 8 there. So if you fill it out, that's what you get. Diameter plus 8 cos theta. Factorize the 8. 2 times 8 and times the 4. So 4 times half times 8 gives you 16. And you've got 1 cos theta here. Don't forget the sine theta there too. Okay. So what am I guiding you through? This gives you the area formula now. So you got the area formula. But they said find the area of the trapezium in terms of theta, which I have. Next, hence find the maximum area. So now that I've got the area formula, then the max area occurs with the derivative equals 0. So you have to find derivative. Now from this point, you could use a calculator to find the derivative and then solve from there. I did it by hand. So product rule, I'll let u equal to 16 sine theta and then v equals 1 plus cos theta. Derivative of both. VU dash, this is what VU dash plus UV dash. What I did next in this next step, if you're wondering where the gaps were, expand the brackets. Cosine of theta times 1, cosine theta times cos theta. And this is what you get. Now, for the ones from last year, special students generally know this, but if you didn't know, you can convert sine squared of theta because that's all in cos theta. You can convert it with this property. That was called the Pythagorean theorem, or property from year 11. Sine squared of theta plus cos squared of theta equals 1. You can kind of figure it out logically by thinking of a triangle. That's theta. This is sine theta. This is cos theta. So using Pythagoras' theorem, square A square B must equal the radius of unit 1. Okay, so that's where they got this property from. Rearranged it to get sine squared of theta must then equal to 1 minus cos squared of theta. Expand the brackets and you should get up to this step. So if you got stumped, might have been from here to here. Okay? And if you did it all correctly, you would have got 16 outside the brackets, 2 cos squared theta plus cos theta minus 1. Factorize that and solve. So you can again let cos theta equal to t, or another parameter, and then factorize that using quadratics. So with my guidance there, it should get you to get 2 possible answers. You got pi and 3, 5 pi and 3, etc., and then pi, 3 pi, etc., to equal to -1 or half. And since we know that based on the diagram, angle theta is in the first quadrants between 0 and pi and 2, it means the only angle that works is pi and 3 for the trapezium to exist. And that probably would have been the key thinking point. Once you know theta is pi and 3, sub it back into your area function, and you should end up with 12 root 3 as your answer. Okay, so this one was a really nice question to work with. That was from your textbook. I think it was 10G, not 10F, question 10. So if you want to have to look at that again, at least you've got my solutions to guide you. But that's mainly 10E, 10F. Okay. We'll do one last example on 10G, and that's just to give you a vibe of what you need to practice and get yourselves ready. Okay, so let's flip over to 10G. Let's have a look at 10G. Let's pick, what can we do with 10G? What's this? Parameters, that's okay. Functions parameter. Could do this one, although it's another derivative question. We'll try this one. 10G question 6. It's from your textbook. All right, here we go. 10G question 6. Again, you're just working with parameters. Let's see if you can work through this. 10G question 6 says the graph of f of x is x to the power of 4. So here's x to the power of 4. Translate it to the graph of y equals f of x plus h. Okay, so you got y equals f of x plus h. Part A. Find the possible values of h if f of 1 plus h equals 16. Sounds hard, but it isn't. What is it asking me to do? Well, how would you start off this question? Hands up if you have an idea. Part A. Part A, find the possible values of h if f of 1 plus h equals 16.
I'd first find f of 1 plus h. Should be 1 plus h to the power of 4.
Beautiful. Sounds scary, but all it's saying is if f of x is equal to x to the power of 4, then f of 1 plus h is just a substitution. So it becomes 1 plus h to the power of 4. Then they say f of 1 plus h equals 16. So therefore, you've got an equation 1 plus h to the power of 4 must equal to 16. Now we can solve for h. Sounded scary, but it wasn't. How do you solve for h now? What's the next step? How do I get rid of that power of 4? Phoenix. How do we get rid of this? Do the fourth root. Beautiful. Do the fourth root. So to the power of 1/4. To the power of 1/4. And that gives you 1 plus h equals 2. What's the fourth root of 16? 2. And then minus 1 on both sides. Correct. Therefore, h is equal to... Yes, it should be 2. So possible values would then be plus minus 2, minus 1. So that gives you... What's that? 1 or negative 3. Okay. So far, so good. B. The graph of f of x, which is now a different one, x cubed, is transformed to the graph of y equals f of ax. So there's a parameter there. Find the possible value of f of ax. I think that's if. If. That should be if. If f of ax passes through the point with coordinates 1, 8. What's the next step now? How do I then solve this one? Let's go with Luke. Part B. Got f of x is x cubed. It transforms to y equals f of ax. If you know that f of ax passes through the coordinates 1, 8, find the possible values. What would you do? So I'm in which point? Into? Very good. So we already know y equals f of ax passes through 1, 8. So literally it just means when x equals 1, y equals 8. Here we go. Y equals 8 is here. F of a times 1. That gives me f of a is equal to 8. What do I do next? That's right, your shot now. What would you do, Erwin? So now I've got f of a equals 8. How do I solve the problem? Yeah. Right there. Got your A there. So we're back in here. So what's f of A? Well, it's equal to 8, yes, but what's f of A? A to the power 3, because we're substituting f of A, which is the same thing as saying sub A into that function there. So you get A cubed, but then to solve for A, how do you do that? Yeah, you cube root both sides. So cube root 8, and we know that equals to 2. So far, so easy. Okay, so that's part A. Part B. Part C is similar. This time you probably likely have to do simultaneous equations because there's 2 parameters. There's A and a B. Has a turning point with coordinates 116. Find the values of A and B. Now, I know that most of you probably will be able to figure out. The main thing is to get your 2 equations. How? Can someone explain to me, how do I get 2 equations from the 1 point? Because you would say sub 116. So I'm like, yeah, cool. You can sub 116. So 16 equals A times 1 to the power 4 minus B times 1 cubed. Everyone gets equation 1. Where's my second equation coming from? Why? Who said that? Yeah. Very good. A typical chapter 10 question. Stationary points is also a turning point. So it means you have to find the derivative with parameters. So here, delta y, delta x. Treat A as a number, so you should end up with 4ax cubed minus 3bx squared. There's your derivative. And you know the turning point or stationary point occurs when x equals 1. That's how you get your second equation. Okay, so then you get 2 equations, 2 unknowns, simultaneous and solve. What you just saw there, that's a typical exercise 10G family of curves. You're literally just working with parameters like you have in the past. Okay? In order to do this again, like I said, you have to know chapter 9 derivatives, chapter 10 tangents, stationary points, normals, maximum, minimums is pretty much what you're practicing. Okay? That's now 11:09. We've covered the key essence of 10F, 10G, and 10E. Last exercise we got for chapter 10 is next week, Newton's method. All right, so Newton's method is next week. Make sure